Welcome or welcome back at C Square. In this lesson, we'll talk about trapezoids. And first of all, let's take a look. This is the definition of a trapezoid. Is a quadrilateral, so four sides polygon with exactly one pair of parallel sides. You can see it right here. The parallel sides are called bases, okay, like AB and DC. The non-parallel sides, AD and BC, are called legs. A leg and a base form a base angle, so these two are what we call base angles, A and B. I'm going to mark them different, they are not congruent in this case. And also D and C are also base angles. Now let's take a look to this first problem. We have a trapezoid. How do we notice that? We notice we have two parallel segments here, DC and AB. So we have a trapezoid, and we need to find the measure of angle A. This angle A you see here, and this angle that is right here, 105 angle D, are supplementary. They are consecutive angle or interior or same side interior angle. If you look to DC and AB, they are parallel lines. These angles are same side interior angle or consecutive interior angle. So these two angles are supplementary. So the measure of angle A plus the measure of angle D equals 180. Angle A is the one that we need to find out. The measure of angle A plus 105 equal 180 degrees. Subtract 105. And we have the measure of angle A is 75 degrees. This is part A. For part B, very similar. We're looking to find the measure of angle C if the measure of angle B, this one, is 2x plus 20, and the measure of angle C, this one, it's 3x plus 10. The same property, these two angles are supplementary. They are same side interior angles or consecutive interior angles. So measure of angle B plus the measure of angle C equals 180. The difference here, we're going to have two expressions. 2x plus 20 plus 3x plus 10 equals 180. So my first thing here is to combine like terms. In this case we have these two terms that have x's, so that will be 5x, and then we have these two numbers, 20 plus 10, that will be 30 equals 180. I'm going to subtract 30 on both sides, and we have 5x equals 150, and the last thing we're going to divide by 5. I mean, not really the last thing for finding x is x equals 30. Now if you notice, we need to find the measure of angle C, and angle C is 3x, so 3 times 30 plus 10. 3 times 30 is 90 plus 10, that will be 100 degrees. And that is for this example that you need some algebraic skills. On my next thing, we're going to take a look to a special trapezoid, which is called Isosceles trapezoid. This is a trapezoid which legs are congruent. So you notice right here, these two legs are congruent. It is a trapezoid because we notice these two sides are parallel sides. Let's see the property of the isosceles trapezoid. The base of the trapezoid are parallel. That's true for any trapezoid. Legs of the trapezoid are congruent. That is the property. That is the beginning of an isosceles trapezoid. Each pair of base angles are congruent. So now these two angles are congruent, and then these two angles are congruent. Another important property, diagonals are congruent and opposite angles are supplementary. And you will see we're going to do some proof at the end of this lesson. So now let's take a look and see what's going on here. We have to find the measure of angle B, C and D, and we know this angle A is 65 degrees. So the first one I'm going to find is angle B, this one. Angle A and angle B are congruent. Those are the base angles. So the measure of angle A is the same as the measure of angle B. So which means the measure of angle B will be 65 degrees. Now let's take a look and let's find one of these triangles, C or D. So let's say we're moving to angle C. Angle C is congruent with angle D, is not congruent with any other angle, but it is supplementary with either angle A or angle B. So that's going to be my property. A measure of angle A plus the measure of angle C will be 180. Opposite angle in a isosceles trapezoid are supplementary. Okay, so now we have here 65 degrees plus the measure of angle C equals 180. We're going to subtract 65 on each side. So we have the measure of angle C equals 115 degrees. So, and we have one more, angle D, which I said it's congruent with angle C. They are base angles. So the measure of angle D will be also 115 degrees. A very similar problem, only difference, we have some variables there, so we have to use some algebraic equation to solve it. Find the values of the variables and find the measure of angle 1. So first of all, I'm going to have to find this x, and I'm going to look to this expression and this expression, which represent the measure of angle A and B. Those two angles are supplementary, so that's the thing I'm going to write here. The measure of angle A plus the measure of angle B equals 180. Okay, consecutive angles in this trapezoid, and these are not both base angles, let me be sure. Or think about BC and AD, they are parallel lines, these are same side interior angles, they are supplementary. So we have 4x plus 11x plus 15 equals 180. We're going to have 15x here because we combine these two terms that have x, plus 15 equals 180. I'm going to subtract 15, and I have 15x equals 165, and the last step to find x, divide by 15 on both sides, and I think that is 11. This is the value of the variable x. Let's see what else we can do. Now we can find the measure of angle A, which is 4x, so 4 times 11, so that will be 44. And now we can move to angle 1. Angle 1 is congruent with angle A because they are base angles, so they have the same measure, which means the measure of angle 1 will be 44 degrees. And we have one more thing to do. We need to find this variable m. So now let's take a look to angle C. Angle C is the same measure of angle B. That's one way to look at. So the measure of angle B is 11x, so 11 times 11 plus 15. So that will be 121 plus 15, that will be 136. Measure of angle B. of course we could have done 180 minus 44. That means angle C is the same, because they are base angles, and this is an isosceles trapezoid. So now we're gonna have 8m, that is the measure of angle C in the picture, equals 136 divided by 8. And we have m equals 17. And that is about this problem. Let's see what's going on in the next example, where we have a trapezoid. We can see that here, and is an isosceles trapezoid. That is important. And now we need to find the value of x if we have these two expression for mt, which is a diagonal of this isosceles trapezoid, and nr, which is the other diagonal of this isosceles trapezoid. So let me put that here first of all. M R T N is an isosceles trapezoid, which means that MT and NR are congruent. The diagonal in an isosceles trapezoid are congruent, which means they have the same length, which means this equation, 2 times the quantity x plus 10 equals 3 times quantity x minus 7. And I'm going to use distributive property on both sides. So we have 2x plus 10 equals 3x minus 21. I will subtract 2x here, I think is better. Obviously you have to do the same thing on the other side of the equal. And we have 10 equals x minus 21 at 21. And we have the value of x, which is 31. No, not 31. I'm so sorry. I missed the distributive property. Here is 20. And with 20. So this will be 41. Okay. Now let's move to what is called coordinate geometry. We have a quadrilateral ABCD. We can see it. I already plotted here in this picture. If you do not have it, do it. I will suggest you. A is -1 and 3. We can see that. B 2 and 4. Yes. C 5 and 1. And D -1 and -1. In part A, we need to show that this ABCD is a trapezoid. So we need to find those two parallel bases. And the only one they look like in this case are these two guys. So let's see, are these two guys parallel segments? And I'm going to erase it. Let's just not do it because we didn't prove it yet. And how am I doing that? If I have the picture, I will personally use this slope triangle. And I can see here I have a rise of 1 and a run of 3. So the slope of AB will be 1 over 3, and is positive because it's going up from left to right. Let's take a look to the slope of DC. The opposite side. And again, I'm going to draw this triangle, and I'm going to count, and I have a rise of 2, right, and a run of 1, 2, 3, 4, 5, 6. Okay, and which can be simplified as 1/3. If you notice, these two are the same, these two slopes, so that means AB is parallel with DC. Now, if we take a look to the picture, AD has an undefined slope and BC it's not undefined. So yes, this is a trapezoid. We know now. Okay, because those two segments, the bases, are parallel segments. Now on part B, we are asked to see if this one is an isosceles trapezoid, which means we need to take a look to the length of AD, which is easy. The length of AD is 1, 2, 3, 4. We can simply count. And then let's take a look to the length of BC. For that reason, again, I'm going to use this classic triangle. And if you notice, this is 3, this is 3, this is a right triangle. I can use Pythagorean theorem to find how long BC is. Or if you learn special triangle, that's another way to do it. Okay, so we're going to have a square plus b square equal c square. A and b are these threes. 3 square plus 3 square equals c square. So c square will be 9 plus 9, which will be nothing else than 18. So c will be square root of 18, but c is nothing else than bc. And I'm looking now to this expression, to this radical, square root of 18 and AD. Square root of 18 is not 4, it's a little bit more than 4, right? In fact, square root of 16 will be 4. And this one is, by the way, 9 times 2, and that will be 3 square root of 2. So we notice these two guys are not the same. So this one is not a isosceles trapezoid. Let me write that here. ABCD is not an isosceles trapezoid because these two legs are not congruent. Okay, on the next part of the lesson we will take a look to what is called the mid-segment of a trapezoid. And very similar with triangles, the mid-segment has some property, also over trapezoid has some property. You can see them right here. The mid-segment is parallel to the basis, that is one property. And the second one, the length of the mid-segment is half the sum of the length of the basis. Okay, you can see that also here in this format. So let's see how we use this property to solve some problem, and you're gonna take a look to this problem first. We have this figure where EF is the mid-segment of the trapezoid ABCD. So we know it's a trapezoid. So now we need to find the length of EF first of all. So EF, since it's a mid-segment, is gonna be the average of the bases AB plus DC divided by 2, and that will be 18 plus 34 divided by 2. That will be 52 divided by 2. Now EF will be 26. Now I want to put this 26 here to see something that is useful. Look at here. 18 plus 8 is 26. 26 plus 8 is 34. That is a way to check it, or you eventually find it if needed. Okay, the length of EF and check it if that is correct. So this was the first thing here. Let's move to the next thing, the measure of angle AEF, which is this guy here. That guy is going to be congruent with this one. Why? Because these are, how we call them, corresponding angles. And corresponding angles are congruent. Okay, how do you know they are corresponding angle? This mid-segment is parallel with the basis. So the measure of angle AEF will be nothing else than 70 degrees. And the last part in this problem is to find the measure of angle BFE, which is this angle here. This angle and angle B are same side interior angle or consecutive angles, and those two angles are supplementary. So let me write that here. Measure of angle B plus the measure of angle BFE, the one we need to find out how much it is 180. And again, the reason, same side interior angles. Angle B is 130 plus the measure of angle BFE equals 180, and my last step would be to subtract 130 here. So the measure of angle BFE will be 50 degrees. The next example, very similar. We have a trapezoid, and where LP is the midsegment of this trapezoid, we need to find the length of FG. So now let's call this one X, and LP will be the average of FG and NM of the bases. So in this case we have 42, how long LP is, FG, do you remember I call it X, plus 63 over 2. So we have an equation, and how do we solve this one? I think the best way is to multiply by 2, because you want to cancel these two. You notice I multiply on both sides, so here I'm going to have 84 equals X plus 63, subtract 63 on both sides, and we have X equals 21. This will be 21, and if you notice, 21 plus 21 is 42, 42 plus 21 is 63, so we have the same difference. So FG will be 21. On part B, the last part of this problem, we need to find the perimeter of FGMN of this trapezoid. So we know the base is 21 and 63. We need the legs. Look at here. This is 13. This will be also 13 because the mid-segment connects the midpoint of the legs. So this is going to be also 13. And also if this is 15, PM will be also 15. So now, how do we find the perimeter of this guy? We add all these numbers we see on the picture, not all of them. Let's start with 63, the long base, and then we have these two 13s, which represent half of the leg FN. So we're gonna have a 26 here, which is leg FN, plus 21, the short base FG, the one we found out, and plus 30. So we have to add these two four numbers. Don't add 42, the mid segment, no reason. And I end up with 140. The perimeter of this trapezoid is 140. Okay. And this one, first of all, let's do some changes, because I have the wrong label. So here below, where EF is the mid, this one is PV. So the PV is the mid segment. Find the mid is the midpoint of the trapezoid. MNTR, so sorry, and we need to find the length of PV. Okay, good. So apologize for this situation, and by the way, we don't need this last part, so just the first part. So how are we gonna find the length of PV? Okay, so this problem is the same, the only difference we're gonna have more algebra, but PV should be half of MN and RT if you add these two. So PV, which is 2x plus 2, will be half of 18 plus 3x minus 1. And if you remember, we did something very similar. I multiply by 2. I'm gonna do the same thing. Multiply by 2. I'm gonna put a parenthesis here because we multiply the whole thing, right? So we have here 2 times 2x, that will be 4x. 2 times 2, that is 4, equals, and on the other side we have 3x, and 18 minus 1, that is 17. Then I'm going to subtract 3x here, and I have x plus 4 equals 17. And the last step for finding x is to subtract 4. We'll end up with x equals 13. Now we don't have to find x, but we have to. We need to find how long PV is, and that will be 2 times 13 plus 2, 26, 28, right? So PV is 28. In the last part of this lesson, we will take a look to some proofs. And the first one, we need to prove that we know that this is an isosceles trapezoid. So DC and AB are parallel. And also these two are congruent because it's an isosceles trapezoid. Can we prove that the diagonal, and if you notice AC and BD are the diagonal, are congruent? For that reason, you want to take a look to these two triangles. I'm gonna try to draw them here. The first one is this one, where we have A, D, and B. Okay, let me mark like this, which is the leg AD. Then we have the second triangle. Hopefully I can do something very similar. This one is not exactly the same, but hopefully. This is A, this is C, this is B, this is the second leg. Now we have noticed this is a common side, and also this is an isosceles trapezoid, which means the base angles, which is this angle, and this angle, are congruent. So we notice here these two triangles are congruent. They don't look in my picture, unfortunately, by side angle side. So then we have the diagonals congruent because corresponding parts of congruent triangles are congruent. So that's the kind of rough draft. I will do it before I will do a proof. I'm gonna do a 2-column proof here. You can do a flow chart, and if you remember, on the 2-column proof we have statements and reasons, and I'm gonna try to put everything we talk about in this rough draft. Okay, so first of all, let's start with what is given. A, B, C, D, isosceles trapezoid. Given. Based on this, we're gonna say what? We're gonna say AD congruent with BC, and this is the property of an isosceles trapezoid. Legs of isosceles trapezoid are congruent. Also, because this one is an isosceles trapezoid, the base angles are congruent. But the only thing, I will have to use 3 letters. Angle DAB congruent with angle CBA. And the same reason is an isosceles trapezoid, so base angles so that's what I meant here, base angles are congruent. And also we have the last thing here, which is AB congruent with itself. You remember that is called reflexive property. Reflexive property of congruency, if you want to be accurate. So now we can say about the 2 triangles I drew, triangle ADB congruent, and the second one you really need to be sure you put the corresponding part, so it's going to be triangle BCA are congruent based on, again, what's the theorem, what's the criterion that you can use here? Side angle side theorem. And now, based on the fact that these 2 triangles are congruent, we can say AC congruent with DB. Why? Corresponding parts of congruent triangle are congruent. So this is the way to prove, hey, if I have an isosceles triangle, then the diagonals are congruent. In my last thing, we're gonna do the converse of this theorem, where we know that ABC is a trapezoid, so we still know that. We know the diagonal are congruent. Is this triangle an isosceles trapezoid? So this is a very interesting theorem, is the converse. And for proving this, look at here what I'm doing. I'm gonna draw these dashed lines CE, which is parallel with DB. Okay. Remember, AC is congruent with DB, and DB will be congruent also with CE, because that will be a parallelogram. So let me write that here, that CE line CE, but let's say segment CE, it's parallel with segment DB. So therefore, and these 2 are parallel given to us. So therefore, we can say from these 2 statements. So this is kind of a paragraph statement proof that ABCD, no, not ABCD, BDCE is a parallelogram. And based on this, I can say then CE congruent with DB. But also what was given, if you remember, it was given that AC is congruent with DB. So remember, the diagonals are congruent. We need to prove the trapezoid is isosceles. So AC congruent with DB. That was given. So based on these two statements, what can I say? I can say CE is congruent with AC by transitive property. But what does it mean if AC is congruent with CE? It means that triangle ACE is an isosceles triangle. Which means the base angles are congruent. These two angles are congruent. Good. But also this angle here and these angles here are congruent because they are corresponding angles. Okay, so based on these two statements now, I can say angle CAB congruent with angles DBA. That's something very important now, because I can go in my original picture now. Let me go back here. And we know now these two angles are congruent. So we're going to take the same triangle like in the previous proof. The triangle ACB. And we know this is the angle I mark. And then this triangle ADB, and these are the congruent angles. Now AC and BD are congruent, that was given, and also AB is a common side. So these two triangles are congruent, so obviously now the corresponding parts are congruent, corresponding parts of congruent angle are congruent, which will be BC and AD, which are the legs. So that's my last part of this proof, or I can do a two-column proof like we did in the previous one. So yeah, this problem is a combination of a paragraph proof and a two-column proof. So we're gonna have statements here and reason here. and we're gonna say angle CAB congruent to angles DBA. And the reason is we did a paragraph proof. Okay, then we have AC congruent to BD. This was given. And then we have AB congruent to itself. Reflexive property. And then obviously now these two triangles are congruent, which we did it in the previous example. CAB congruent to DBA, triangle DBA. So again, you need to be careful. And the reason now is side angle side theorem. So now we know BC has to be congruent with AD because corresponding parts of congruent triangles are congruent. And now, what does it mean this? This means ABCD is a isosceles trapezoid and why? Because legs are congruent. Okay, so the interesting thing about this theorem, you need to do this extra drawing and extra paragraph proof to prove those two angles are congruent. If you enjoy this lesson, don't forget to click the like button and come back and see square for more help. Thank you.